So we know that the strength of an acid or a base depends on its tendency to ionize. It's not the molarity. That might refer to concentration, but acid or base strength is the tendency to ionize and form hydrogen or hydroxide. One factor that can affect the strength of an acid is the electronegativity of the atoms bonded to the hydrogen. So it says here, as hydrogen is bonded to atoms with higher electronegativities, the electrons are more strongly pulled away from the hydrogen atom. So we're talking hydrogen bonded to oxygen, nitrogen, halogens. If the bond involving the hydrogen atom then becomes weaker, it's more likely that the hydrogen atom will dissociate, resulting in a stronger acid. So here's really two really good examples. Below are Lewis structures for nitric acid and nitrous acid, respectively, in that order. So the first one is the nitric, and the second one is the nitrous. Which acid is stronger? So they're really, really similar. We've got the hydrogen. Both hydrogen are directly bonded to an oxygen. That oxygen is directly bonded to a nitrogen, which then is bonded to either one more oxygen or two more oxygen. So we're dealing with some pretty electronegative atoms here. Poor little hydrogen being bonded to oxygen and nitrogen. And so obviously the electrons in this bond are being pulled away from the hydrogen toward that electronegative oxygen. But then here, when I've got all these other atoms with really high electronegativities, the electrons just keep getting pulled away from that poor little hydrogen. But something similar happens in the nitrous acid. Obviously, the electrons are pulling away from the hydrogen, and then they're still being pulled away and away. But as you have more oxygen in the nitric acid, there's just more pull. It's like a tug of war, but then one side ganged up and said, I'm going to find like 4 friends versus poor little hydrogen. And then the second one, we got hydrogen versus 3 friends. And so I get this situation where here, like all of these guys are highly electronegative, pulling the electrons away from hydrogen, 4 highly electronegative atoms versus 3. Either way, hydrogen is just doomed, right? That hydrogen is not going to last for long. But we would say that this first one, the HNO3 nitric, is stronger. There's more highly electronegative atoms pulling electrons away from poor little hydrogen. He's got no chance. And so if there's more atoms pulling the electrons away from the hydrogen, that bond becomes weaker, and then it's a lot easier to lose my hydrogen. That results in a stronger acid. Here's another good example. Below is the Lewis structure of hypochlorous acid. Draw the Lewis structure of hypoiodous acid. Which is stronger? Justify your answer. Well, last time I checked, halogens all have the same Lewis structure, so the Lewis structure of this second acid should be almost identical. Now, I'll even draw it with the proper angles here. We've got like a bent structure. It's kind of like an upside down bent, where the oxygen would have its 2 single electrons and then 2 lone pairs. Each of those single electrons would bond. One will go to the iodine, and one will go to the hydrogen. There he goes. So it's going to look almost the same. We're just going to replace the chlorine with a hydrogen. Same bond angles, same bent structure. It's great. All right, now I have to figure out which is stronger. So again, since we have such a similar structure, the only difference is the halogen. It's got to have something to do with the properties of chlorine versus iodine. And it's an electronegativity issue again. Both of the hydrogen are directly bonded to the oxygen. So right there, the electrons are being pulled away from the hydrogen. But then again, it's like a tug of war. Each oxygen called for another friend. Well, the first oxygen called for chlorine, and chlorine's got a higher electronegativity than iodine. So it's like here we got a really strong friend that's also going to pull electrons away from hydrogen. And in the second one, like we grabbed another buddy, but the iodine doesn't have quite as strong an electronegativity. So again, I have something similar where here there's just like a 2 versus 1 situation, but that chlorine adds a little extra pull on the electrons. And here, I mean, this is a good team to pull electrons away from hydrogen, just not quite as strong as the oxygen and chlorine. So to explain it, again, I'm going to say that the stronger acid is the HOCl. Chlorine has a higher electronegativity than iodine, pulling electrons more strongly away from little hydrogen. And again, as I pull electrons away from hydrogen, I weaken that bond, and it's more likely that the hydrogen ion will dissociate, causing the acid to be stronger.